Alright, so we're up to question 10. So we've been given a diagram of a line. They told us to coordinate 3 of the points. They then asked us to find the midpoint of CB. So we've already talked about the midpoint, remember? What do we do to find the midpoint? The point is the coordinate, or the head of the midpoint. Good. So we're going to do 5 plus 0 divided by 2, and then we're going to do negative 1 plus 4 divided by 2. And that is going to be a coordinate. Now you've got to be careful when you're doing these divisions that you are entering into a calculator. You need to either use a bracket or put them in as a fraction like that, or press equals once you've done the top. Some people mixed up the x and the y. They got the y's and then the x's. You've got x comes before y in the alphabet, x comes before y in the coordinate. So 5 plus 0 is obviously 5, divided by 2 is 5 over 2, or 2.5. And then negative 1 plus 4 is 3, so that's 3 over 2, or 1.5. Okay, so you either have 2.5, 1.5, or 1.5 over 2, 3 over 2. Shh. Yep. Okay, but if you've got issues with your test, then I'll deal with them afterwards. Okay? So find the length of the line AB. Some people thought they were still talking about CB. Okay, so you've got to make sure you're reading questions. This is AB, so now we're trying to find AB. It says using Pythagoras' theorem, but that's how we learn how to do this. Try not to TikTok today, Elsa.
I wasn't just talking.
Oh, I saw some. Well, then put everything under the table.
I wasn't.
Okay, how do we do this?
I did the square root of y squared in brackets. Y squared. Y2 minus y1.
Okay, yeah, so that's just that's the formula. So let's try and use some numbers.
Okay, so it would be 4 minus 0 squared plus 0 plus 2 squared.
Yep, I'm actually going to write minus negative 2, just so that we are understanding it's the same situation. So it's the difference between the y values, so that's the 4 take away 0, and that's squared, and then the 0 take away negative 2, and that's also squared. Some of you are still believing your calculator when you type in negative 4 squared, you believe that that's negative 16, okay? The reason it's not is you know that 2 negative numbers multiplied together
Make
a positive, and it's because you're not using brackets when you enter it in. Julian?
It was -4 though. It's just
No, some people did the other way around. So they did 0 take away 4 and negative 2 take away nothing.
oh. I had no idea why I was just raising my hand. I'm sorry.
Okay, right. So you've got here 4 squared, so that ends up as 16, and negative, so this is positive 2 squared, it's 4, so that's root 20. Okay, you can leave it as root 20,
Oh, I was so
or you
close.
can write as a decimal if you wished.
If you left it as like a third, is that okay? So, no, I'm not third. I mean, if you left it as like 2 bracket thing 5, is
Yeah.
that okay?
Is triangle ABC isosceles? Show working to back up your answer. So you're not going to get any marks for saying yes or no. Okay, just FYI, because that's a 50-50. And they've said you need to show working. So you have to go back to thinking, right, what do I know about an isosceles triangle? What feature of an isosceles triangle do you think they might be looking for? Yeah.
Was it the angles of each corner equal 180?
No. All angles in a triangle add up to 180. That's not helping us to find why it's isosceles. Elsa.
I'm sorry.
Elsa has an actual
The length
addiction.
of the line of the two sides.
Good. So the lengths of 2 of the sides are the same. What about the third side? It's not the same. Okay. So to be accurate here, you need to actually identify the length of AB, the length of BC, and the length of AC. Okay, so you need to identify all 3 lengths. Because showing that two of them are the same is not sufficient to say that it's an isosceles triangle. Because you have to state, but the other one is different. Now, handily, we've already found the length of AB because we did that up above. Okay, so now we just need to find the length of BC and the length of AC. Bless you, what band was they on? Right, so Hayley, could you tell me how to find the length of BC? It's going to be similar method to this one here.
I don't know.
You don't know. So I've just tried to give you a clue. It's a similar method to this one here. It's just going to be different numbers. So did you follow what we did there in part B? Remember the conversation we had yesterday? If you don't follow something, you need to let me know.
Of BC,
BC. So now we're using the coordinates for B and the coordinates for C.
0 plus 4
I can't see the numbers, so I'm assuming you're right.
over 2. I mean squared.
Okay, is it plus or is it take away?
Plus. Well,
Okay,
how do you know?
Okay, so when we did this one, remember you're subtracting one coordinate from the other because you're finding the difference between them. The only time that we add is when we're finding the midpoint.
Okay.
Okay.
Then minus
So, sorry, what were the numbers again then?
0 minus 4 squared.
Yep.
And 5 minus negative.
And what am I doing with those?
Oh, plusing.
Yep. And
Plus
so
5 minus negative 1.
squared. Yeah. Are you happy with that? Right. So 0 take away 4, and then when you square it, that's going to give you
Positive 16.
good girl, positive 16, and then 5 take away negative 1 becomes
Plus so 6.
6, and 6 squared is
36.
good, and 16 plus 36 is
52.
good. Good mental maths. Okay, so that's BC. Now we're going to find AC. Okay, Julia.
What does an isosceles triangle look like?
Okay, that's awkward. We just discussed that.
No, I know, but can you draw it, please? But no, the other line is the same length.
No, but if it was, I'd have a dash on that as well.
Oh, that's
That
what
would be
I
an
drew, but
equilateral triangle.
it's really. Okay.
My name's not Shirley.
No, I mean, they're. Aren't this one and this one like the same length? It looks like they're the same length, though.
It's not drawn.
Angel,
Can I see this
it's
one?
not. You've got to always appreciate that diagrams, if they've drawn them, are not drawn accurately. Okay? So you cannot assume anything.
But couldn't it also be an equilateral?
No, because
This is what we're going to show, sweetheart.
Oh, right. Sorry.
Remember that conversation?
Yeah, I mean like the drawing, but okay, it's
Were you
fine.
TikToking in a minute ago?
Me? No, I have not been talking this whole lesson.
Alright, okay. So AC, and I thought you were going to tell me the answers. Actually not.
Oh yeah.
Over
Julia, you're not going to go through this?
Oh yeah, sure, I'll go through it. So AC, you would do -1 minus 0 squared plus 5
Pardon?
minus -2 squared.
Okay, as I said, I'm not looking at the numbers, so I'm assuming this is right.
And then it equals -1 squared, well, which is 1 plus 49, because that's 7 squared.
So something's gone wrong.
Is there some 50?
Something's gone
Hello?
wrong. It is.
That was Danny Stalker.
What?
I'm sure.
Yep.
Sorry, I was just looking off my paper, so. And I got it wrong. Miss Harrison, there was a little kid that tried to get in our class.
Pardon?
There was a little kid that tried to get
That's
in our
fine.
class. Oh, what? Sorry, I am so sorry. That is not right. Okay.
A and C.
Wait, yes it is.
A and C. They.
Yeah, it's right.
It's right. I got that.
Or then something.
How's that
Then
Yeah.
BC is wrong. Oh, girls, come on. What?
Yeah, it's not zero. For BC. BC is not 0. It's mine. It's
Yeah.
Okay, so this should be -1.
Yeah.
So -1 minus 4 is
Oh yeah, because
Can it fit
for BC. Yeah, it's 4
Yeah, the answer is
Minus-
50,
minus
not
four.
52.
plus 0 minus 5.
oh gosh, what is going on here?
Yeah, I have -1 minus.
Coordinate and
Yeah, it is.
But this should be a 0.
y in the x.
Yeah, I have -1 minus 4 squared plus 5 minus 0 squared.
Yeah, so this was the wrong way round. Okay, so we've got, this is 5 squared plus 5 squared, so this should be root 50.
How's this thing
Okay, ladies, if you see something that's wrong, please let me know.
I didn't know.
I couldn't keep saying to you, I can't see the coordinates anymore. I'm trusting what was being told to me was right.
I didn't know what's wrong.
We also have to help out whoever is doing it. So, having done this, we've now got root 50, root 50. So it seems to be we can say, oh, it's an isosceles triangle, but we must add on the fact that this one, the AB, is not the same value.
Because
Okay.
it could be equilateral.
Because otherwise it could be equilateral, exactly. So we can say the triangle is an isosceles
Wait,
because
let me get my ring.
No, it wouldn't not be isosceles.
Is it mommy?
and AC are equal.
Miss
But
Harrison.
1 second, Angel. AB is different. Okay, so we know that an isosceles triangle has 2 sides that are equal. So I've just shown that this side and this side are equal. I've also stated that AB is different because we found that that was root 20. So that's the rule for an isosceles triangle, Elsa.
Does it not have,
2 are the same, 1 is different.
so it doesn't have to be like this 2 on the side?
No, doesn't matter where it's drawn. The
Oh.
features of an isosceles triangle are that 2 of them are equal, 1 is.
Also, can you please turn on the AC?
No, take your jumper off first.
Oh, it's so hot.
Alright, next one. So, girls, let's try and get this done as quickly as possible because it's dragging on this.
Because I want to.
Right, so ABCD is a rhombus. Now, you will find that we have questions like this that you may sit there and go, what's a rhombus? Okay? You need to make sure that you are aware of these kinds of things. So, does anyone know what a rhombus is?
A square?
Erin?
It is 2, 12, 5. No,
Just 2 parallel sides?
4.
Depends how you're describing it.
It is a quadrilateral.
It is a quadrilateral. I need more than that.
I don't know.
Oh, me.
I know.
Slanted. It goes like that. And
What's that called? Come on, guys. This is good review of shapes.
We don't do
Cheyenne?
2 pairs of parallel sides.
Okay, it's 2 pairs of parallel sides. I need more than that though for a rhombus because 2 pairs of parallel sides would be a parallelogram. Okay? Julia's changed her mind. Gabby?
All of the sides have the same name.
All of the sides have the same thing. Okay? Haley, were you going to add something?
It's a tilted square.
It is a tilted square. Perfect description.
Isn't that a parallelogram?
Oh my giddy aunt.
What do parallelograms look like? Sorry, I'm getting confused.
My angel, I just said parallelograms.
Don't have all these.
Okay.
No, look at you, Cheyenne. You don't weigh the people outside.
I didn't. No one's there.
Well, then why did you do this?
No, I was offering them right now.
So, Cheyenne's description was 2 pairs of parallel sides. Okay, but I said we need more than that.
Yeah.
Because 2 pairs of parallel sides would just be a parallelogram.
Yeah.
Okay? Which this is, but this is more specifically a rhombus, which tells me that all of these side lengths are equal.
So parallelograms, not all of them are equal?
Correct, they are not always equal.
Are they right
It's like,
angles?
so you have to remember that in descriptions for quadrilaterals, many of the descriptions are similar. So for example, if I were to describe a rectangle, I would say 2 pairs of parallel sides, all angles are 90 degrees.
Yeah.
Okay? Now, a square fits into that description.
Yeah.
Yes? So a square is classed as a rectangle.
Okay.
Okay, so a square could be in the rectangle family
Yes.
because it fits into that description.
Mhm.
But to ensure that we know it's a square, we would add that all four sides are equal. Okay? Same thing with rhombus.
Yep.
A rhombus fits into the parallelogram description.
So rhombus is basically a tilted square. Oh wait, we just said that. Okay, yes, I got it.
Good. But we go through things which reassure.
Oh, a tilted square.
All the sides of the circle.
Because they are testing that you know what a rhombus is. Okay? And that's the key thing with maths exams is that whilst we've taught you that what the symbols mean, so if you see the symbols, you know that that's. If you see the dashes on them, you know that they're all the same thing. But this is testing that you know that. Okay? Right. Okay, so we've established what a rhombus is. Now, if you didn't know what a rhombus was,
Oh,
then you may have found this question a bit tricky.
I knew what a rhombus was.
Okay.
Yeah, I didn't know what a rhombus was. So it's still fun.
So it says the coordinates of A are 7, 11, the coordinates of B are 17, 11. Find the length of the line DC. So, shivering timbers. We know this coordinate here is 7, 11. Yes?
Yep.
This is 17,
11.
11. Okay?
11.
So how would I know the length of this line? I know that's not what the question's asking me. I know it's not. But how do I know the length of this line? Julia?
Because they're both parallel. Wait, that's a lie. Sorry.
I want to know the value of it, please.
Oh, you find the length of the line?
That's what we're trying to establish. Can we just do it easily and quickly, Hayley?
17 minus 7.
Lovely. The length of this line here must be 17 take away 7. Yes?
Oh, I
Is
thought
that
you were
that?
asking me. Okay, yeah, I got it. Sorry.
So what is 17 take away 7? 10. Okay? If we know this is a rhombus, how do we know what line, what length DC has? 10. Okay? That's why it was just worth 1 mark. Okay? They weren't expecting you to do a lot of work for that. Use the information you've been given. It should have been a straightforward one. We want to find the gradient now of line AB. AB. What's the gradient of line AB? So look at line AB. What kind of line is it? AB. What kind of line is it? How do we describe that line? There's only one of you knows what kind of line that is. Danny.
Straight line.
More than that.
I'm at 80 degrees.
What kind of line does that?
Horizontal line.
Horizontal line. What do we know about gradients of horizontal lines, Lily?
So that they're undefined or 0.
Those two are different.
No, they're both 0.
Okay. So, now look, do I need to send you two out? I don't mean to be rude, but it would benefit you greatly to understand what was going on in this test.
Yes.
Because I'm not quite sure that you knew what was going on at the time. Now, you seem to find that hilarious. So could you go out until you calm down, please? Out. When you're out there, you need to take your ring off. And you're going to place your ring when you come back in on my desk because you're losing it now. I'm not having this, Danny.
I'm fine now.
Out. Just out. Calm down for a few minutes. And when you come back in, you're going to sit somewhere else. You can't cope with sitting over there. So, Lily, you just got a bit confused there, yes? What kind of line? We know that horizontal lines have gradients of
0.
Okay? If you wrote undefined, what kind of line is that?
A vertical line.
Vertical are the undefined. So if you wrote both of them, you're not going to get the mark because those two are actually different. Yes?
Is it okay? Never mind, I can.
Remember, it's your own paper, so you're going to ask me that separately.
No,
Right. So circle the equation of the x-axis. This is something going back to when we were learning about straight line graphs. The x-axis, remember, has an equation. What kind of line is the x-axis? It's a horizontal line, yes? Horizontal lines all have equations of
0.
what?
Y equals 0.
Y equals 0. Horizontal lines are always a y equals a number, and specifically the x-axis would be y equals 0 because it goes through 0 on the...
That was the only one that I didn't circle.
Okay.
Aaron circled like 3 times and crossed it out.
Alright.
Except for that one.
Alright, next one, question 12. So P has a coordinate 0, -1, Q has coordinates 4, 1. We need to find the equation of the line PQ. So to find the equation of any line, remember we need 2 pieces of information. We need to know what?
The coordinates.
No.
Oh.
We need to do y is equal to
We know, what 2 things do we find?
The
When we're trying
gradient and the y and
to
the
gradient and the y-intercept, because we know it's y equals mx plus c.
Oh,
So that's going to be the gradient, that's going to be the y-intercept. Okay, so how do we find the gradient?
You do x y2 minus
So give me
y1.
some numbers.
So 1 minus -1 over 4 minus 0, which equals 2 over 4, which equals 1 over 2.
Okay, so we've got a gradient of 1/2. So we know it's y equals 1/2 x plus c. Now, remember you've been given 2 coordinates. You can stick either or substitute either of those 2 coordinates in to find c. My preference would be to look at this one. Why would I want to look at this coordinate rather than the other one?
Because that one,
Pardon?
It's less working out to do.
Oh, did you want to start with 0? Don't you usually like...
Well, having 0 as my x coordinate already tells me what my y-intercept is, doesn't it?
yeah.
Do you remember? So when one of your coordinates has a 0 here, that already tells you that your y-intercept is -1. So if you can, look out for those coordinates. If you hadn't chosen that one or you'd substituted it in, you should have still found that c was -1. If you didn't, then something went wrong, okay? But I'm just trying to help you out when it comes to exam technique, is to look out for those ones if you can.
I don't know if you just said this, but if you just label that as x and y, and the other one is x2 and y2, can you just speak about y? That's what you just said.
Not really.
That's not what I did. I substituted.
Okay. PQ are 2 vertices of a rectangle PQRS. Find the equation of the line QR. Okay, so P and Q. P and, what did I say?
Q.
P and Q are 2 vertices. So, if here's my P and my Q, I need to find QR. So QR, it doesn't matter where R is, but it's going to be either up here or down here. Do you all appreciate that?
Yeah.
Yes? So if this is PQ, QR is going to be what relationship to that line?
Perpendicular.
Nice. Yes? Are you all happy with that?
Yes.
Yeah.
Yes? So if I know the gradient of this one is what? We just worked it out.
Is a half.
Careful.
Oh, sorry.
Is a half.
Oh,
Yes, so this gradient is 1/2. What would the gradient of QR be?
-2
over.
-2.
Okay, -2 over 1 or -2. Okay, so we know that it's going to be y equals -2x plus c because it was a perpendicular gradient. Yes? But we need to find the full equation, so what do we now do?
Substitute in according to Q.
Good. Now this one, it does matter which one you choose. Okay? Because we know that the line QR goes through the point Q and R. It doesn't go through the point P. You all happy with that?
No.
So, who said no?
No.
one. Alright, I'll go ahead. So, you're going to substitute that value in. So, we've got 1 equals -2 lots of 4 plus C So 1 equals negative 8 plus c, so c ends up to be 9. So we've got y equals negative 2x plus 9. Yeah?
Wait, I have a question.
Yeah.
So you said it matters which one because. Oh, right. Mm-hmm. Okay.
Okay, because it's the line QR, not
Yeah.
okay. Okay? So we know that the gradient of the line P, whatever the other letter would be, is also negative 2, but they specifically said that one. Okay? Right. Next one. They've said that they're on a straight line. Okay? So that means that the gradient of this line would be what in comparison to the gradient of that line?
Bigger. Wait, what? Sorry, I'm confused.
The gradient of this line would be what in comparison to this one?
The same.
Collinear.
The same.
Okay, the words I'm saying, the gradient of them. So the gradient of this one and the gradient of this one. Many of you have said it. I'm not saying it, but some people are not saying it. So the gradient would be the same, yes?
Yeah.
Yep.
Are we all comfortable with that? Do we understand why it's not perpendicular? Yes? So, if they lie on a straight line, then the gradient of AB is equal to the gradient of BC, which is equal to the gradient of AC. Okay, any of those gradients are the same. So what we're going to do is we're going to establish what the gradient actually is. And we're going to then use our coordinates for C in one of those calculations, and we're going to rearrange stuff to find Q. We did do one of these, similar to one of these in our examples. Okay, so let's find the gradient of AB. So the gradient of AB would be change in Y over change in X. So 4 take away 0 over 7 take away 9, which is 4 over negative 2, which is negative 2. So our gradient of AB is negative 2. I'm looking at that going, oh, that actually looks quite good as well because I know my line is downhill sloping. So that makes sense. Okay? So all of these things should be going through your head when you're doing this. Then I'm going to say, right, I'm going to now compare that. So I now need to involve point C. You can involve point C with either point B or point A. Which one do you want to do?
A.
Point A. Okay, so now we're going to compare C and
I did
A.
B.
If you did B, that's fine.
Okay.
You should get the same answer.
Okay.
So Q take away 0 over 1 take away 9 would equal negative 2. We got that value from here. Yes?
Yeah.
If you had looked at B, you would have had, oh, sugar box. Yeah?
This is a different way. I do the y equals mx plus I just substituted the.
As long as you got the right answer, sweetheart, that's fine. Okay? So if you had used point B, you would have had that working on the right hand side. So then we need to rearrange stuff. Well, obviously Q take away nothing is just Q. 1 take away 9 is negative 8. How, if we've got Q divided by negative 8 equals negative 2, how do you get Q on its own? So you've got negative 2 multiplied by negative 8, which is positive 16. Similar thing over here, you've got Q minus 4 over negative 6. So you've got Q minus 4 equals positive 12, and then Q equals 12 plus 4, which is 16. So either way, you end up as Q being 16. Okay? Yes.
I did that a different way. I figured out.
If you've got the right answer, then that's fine. If you didn't, come and ask me afterwards because it's just your individual paper.
I don't know.
Okay. Then if you get the right answer, there are slightly different methods of doing stuff. As long as it's fine, you're good to go. Okay? Next question. We're almost there, people. So, the points with coordinates 0, 3, and 8, 5 lie on a straight line. Work out the gradient. How do you find the gradient of anything?
Rise over run.
Rise over run. So in other words, the change in y of the change in x. You can either do some counting on the graph, because they've drawn it for you, or you look at the coordinates. So if we're looking at the coordinates, we would do 5 take away 3 over 8 take away 0. which is 2 over 8, which is 1/4. Okay? However you do it, that's the answer you should be getting. Okay, so 1/4. Write down the equation, an equation of L. So what do we know? We know the gradient is 1/4. Can we see where it crosses the y-axis?
Yeah.
Where does it cross?
3.
So that means my equation will be y equals 1/4 x plus
C.
3.
Oh, sorry. That's what I meant. 3.
Okay, because it went through the y-axis at 3. Find an equation of a line that's parallel to L, but passes through this line. So we know that parallel lines have the same gradient, so we do y equals 1/4 x plus c. But we're substituting in these values. Shh, girls, stop being rude, please. So -2 equals -1 plus c. So -1 equals c. So we've got y equals 1/4 x minus 1. Okay? I will send you this document, so if you haven't got it down already, don't worry. On the grid, draw a graph of -3x minus 1 from the values -2 to 3. So again, like the one we talked about the other day, if you could plot yourself a little table of values, choose some values, substitute them in, and plot them as coordinates. Okay? What's our other option? Erin?
I just substituted the x coordinate in the y equals mx plus c.
Okay, that's essentially what I just said here, sweetheart. What's the other method?
Oh, I don't know.
Cheyenne?
Like changing, just plotting. So like you have, I don't have to say, you have your first point, which is on -1.
Okay, that's the, what do you mean, -1?
So like when you plot it, you do your first point, which you already know, and then you like backtrack like into the negative or something. Like find the other point.
What features of the graph can we establish from this equation?
The gradient.
Okay, so what's the gradient?
-3.
What does that mean?
3 over 1.
-3 over 1. What's the y-intercept?
-1.
So what could we do? We know we're going to cross the axis at -1.
Yeah.
And having a gradient of -3 over 1 tells me we're doing what?
Going down.
Going down.
How many?
Across straight 1, 2, 3.
1, 2, 3, and across how many?
1.
Now you've got to be careful here. Some of you just did this. What do you need to do? You need to go here. Because look, this is what 1 unit is on this graph.
Ah, shoot.
Okay? So that's where I would have said to you, watch the scale. And then to repeating that, bless you, 1, 2, 3, and across 1. Okay? There's your straight line. Okay?
Okay, if I did it the other way.
Yeah. I'm showing you that's a good way.
Well, why would it say -2 to 3 at the top?
Okay, so it says that, sorry, I actually should make sure I do this, because you need to make sure you extend your line to satisfy between these numbers here. Okay, so your line has to be long enough. If you had just done this, and drawn that little portion, you would have lost a mark for it.
All right.
Okay, so your line has to be long enough to go through those points.
Yeah.
For me to see those values.
Got it.
It seems harsh, but that's the way the mark schemes work.
I got it.
Okay?
Get you.